Let's try to do exercise number 12. Exercise number 12. Exercise number 12. A solid homogeneous cylinder of mass m and radius r, mass m and radius r, was set in rotational motion around its axis with angular velocity omega 0. And then it was placed with its side surface on a horizontal plane. The coefficient of friction between the cylinder and the plane is equal to K. Find in a first part, it is necessary to find the time period when the cylinder moves with slipping. So I will try to draw a picture. I'll try to draw a picture that will explain the condition. This is a horizontal plane. And cylinder on this plane. The cylinder on this plane. And cylinder on this plane. And the cylinder rotates like this. Okay, and what is the direction of angular velocity vector? What will be the direction of angular velocity vector according to the picture? How do you think?
It must be same the moving rotation. In other words, yeah.
There may be a few directions. For example, to the right, to the left, up or down, from us to us. What direction will be here?
So, this thing moves to here. So, but you have already this must be angular. So from top to bottom or something like that.
No. Do you remember the right hand rule? That allows us to define the direction of angular velocity.
So if the rule inside from us to inside.
Yes, from us to the screen.
Mm-hmm.
It is from us to the screen. It will be from us to the screen. It may be drawn like this. Yes, it will be the direction of angular velocity. Okay, so maybe you have some ideas how to solve this exercise, or what to do to solve this exercise.
Your voice is gone, teacher. Tell me again, please.
Maybe you have some ideas what will be the next step in solving this exercise. And just what can we do?
So F equal mg, maybe potential always we can start from, and we can find the acceleration or force, something like that from here. Maybe. I don't know.
Yes, we can show forces. We can show forces, and you are correct that we can show mg, force of gravity. We can show force of gravity, mg, mg, mg. What else? What else do we have here? Because if we have only mg, the cylinder will fall down.
Yes. Okay. Surface. Opposite
Yes,
side of the mg.
yes,
Yeah.
reaction, normal
Mhm.
reaction from forces or from surface. Force of normal reaction. Okay, maybe something else.
So it causes friction.
Friction. Yes, force, the force of friction. The force of friction. The force of friction, F. The direction will be this. If cylinder rotates in this direction, force of friction will be from left to the right. From left to the right, it will be force of friction. Yes, and this force allows us to find the acceleration. To find acceleration, we can use the second Newton's law of motion, ma, mass and acceleration. Ma is equal to force of friction, because mg and n, they are they have the same absolute values, but opposite direction. So they neutralize each other, and this force of friction will cause acceleration. But it is necessary. It is necessary to write. It's necessary to find this force before we find acceleration. It is necessary to find force of friction, because
Yeah.
we still don't know this.
So I don't know.
Maybe you can remember Amundsen-Coulom's law, or law of friction. it will be something like this. Something like this. F, force of friction, its absolute value, is equal to coefficient of friction, K, multiplied by absolute value of normal reaction. Absolute value of normal reaction. So what can we
mg.
mg, yes, kmg, it will be kmg. Okay, it will be kmg, so we can write this here, kmg, and from here we have acceleration. A is equal to E
kg.
kg. Yes, kg. It will be kg. Okay, that's correct. And what else can we find? Maybe we can find something from this acceleration.
It's maybe we can connect with acceleration to angular velocity, you mean? When
Acceleration and velocity. So from acceleration we can find dependence of velocity on time. Dependence of velocity on time can be good from acceleration. And to do this, it is necessary to remember the definition of acceleration. Definition of acceleration, it is first derivative of velocity by time.
So I understood, I think, so velocity equal acceleration multiplicate time. So we know the acceleration. So velocity equal to kgt.
Yes, velocity will be kgt.
You mean?
Velocity will be kgt because from here we have this. We have this is equal to kg, and from here we have dv is equal to kg dt. When variables are separated, we can integrate this equation. We can integrate this equation, and lower limit will be 0 and 0, 0 and 0, and the upper limit will be t and v. And after calculating these integrals, we will get that v is equal to k g t. Yes, it will be dependence of velocity on time. Okay, and this velocity is here. This velocity is here. is v. Velocity v. Okay, and what else can we do?
We can calculate kinetic energy, maybe. I don't know. If you want, yes, we can.
What do we can?
Kinetic energy, maybe if it is necessary, we can calculate right now.
Calculate right now. But we have just symbols. We don't have numbers, so we cannot calculate something. It is necessary just to get the final formula. And we still didn't take into account rotation.
Mhm.
We still didn't take into account rotation, and we still didn't anything about rotation. So what can we do with this? Because we described motion of the cylinder from left to the right, but what about rotation?
And rotation, can we calculate torque? You mean minus FR?
Yes, it is necessary to calculate torque. Torque related to the axis. But first of all, we should choose axis. We should choose axis to calculate this torque. What axis will be the best in this case?
Inside the screen's axis, so I don't understand what you mean. Torque. You are asking direction, am I right?
The direction and the axis, because torque is related to axis, and so this axis should be chosen before we define torque.
So minus X. It must be.
I don't understand. Maybe you can show on picture this axis.
So so if it is X, if it is the Y, so direction must be something like that, X minus X. So I mean this way, inside of the screen. Torque. It must be something like that. Maybe I don't know, it's not clear, but
Yes, I mean axis. Let's choose axis of symmetry of the cylinder. Let's choose this. So we will choose axis of the cylinder. This axis, and if we choose this axis, the distance between this axis, and the distance between this axis and force will be equal to r. This distance will be equal to r, and it is not good. I have some bugs with my screen, but I hope to cope with this. This distance between force and axis, it is r. Distance between force and axis, r. And I'll redraw this. I'll draw another picture to show that axis of rotation is perpendicular to the screen, and from us, it is directed from us perpendicularly to the screen, and r, radius vector r is here. Radius vector r is here, and the force of friction is here. It will be force of friction. And according to this picture, what will be the direction of torque? How to define the direction of the torque?
FR, F multiplicate R. Is that
F
true?
H or R?
FR. Mm-hmm.
Yes, FR, but it is necessary
Direction.
to put the correct order of
Vector.
this RF or FR.
You mean
Because
why
it is
not
not the same if you have cross product. What will be here, RF or FR?
I'm not sure. FR, I think.
It will be RF. And we have to write a perpendicular part of force, perpendicular component of force. And what is this perpendicular? It is part of force that is perpendicular to axis of rotation, and what is perpendicular to the to r. What is perpendicular to r? And what is good that in our case, we can see from picture that in our case, F perpendicular will be the same as force F. So we don't need to We don't need to divide f in different components, because we have this equation according to the picture. Because according to the picture, force F is perpendicular to axis Z and perpendicular to R. And so we can write that it will be R multiplied by F. Okay, and what will be the direction of MZ? It is necessary to remember some properties of vector product to define the direction.
Left to right, then right to left.
So,
no.
According to the properties of vector product, it will be first of all MZ will be perpendicular to R, and MZ is perpendicular to F. So MZ is perpendicular to the screen, but it may be two answers. It may be two answers from us and to us, and only one of them will be correct. So which answer should we choose? Which direction?
Left one.
No, these both are correct. These both are correct, but I mean that MZ will be perpendicular to the screen, according to these two conditions. But perpendicular to the screen may be from us and maybe to us. So what should we choose?
To us.
Why? Because this is correct, from the screen to us. Okay, according to the right-hand rule. I'll redraw this picture again, and I'll put beginnings of vectors F and R together. I'll put beginnings. I'll move this. I'll redraw this picture in such way. And according to vector product, we should consider this rotation of vector R, because it is R multiplied by F. According to the right-hand rule, if we have such rotation, the sum will show the direction from the screen to us. So according to this picture, we have a direction of torque is from screen to us. Direction of torque is from screen to us. Okay, do you have any questions about this?
Nope.
Not. Okay. Okay. If there are no questions, that's good. And here we have a vector equation, and but scalar modulus of this vector will be more useful. How to get this? How to get absolute value of torque mz?
So I believe that we know F kmg.
Yes, we know f, but I mean absolute value of
Value
this,
of this.
because we don't need vector value. We just need only its modulus of this vector.
Yeah, right.
We just need the modulus of this. I mean that modulus of vector mz, which is equal to absolute value of this vector, which is equal to Rf in this case. It will be equal Rf na sinus 19 degrees, because the angle between vectors r and f is 90 degrees, and it will be Rf. But with is necessary to take into account. It is necessary to take into account minus. Why minus? Because the direction of axis and direction axis and angular velocity is opposite to the torque. Torque is opposite to the angular velocity, so it will be minus kmg r. Okay, we have found absolute value of torque, but not absolute value. Projection of what is necessary to write like this, because absolute value cannot be negative. Minus absolute value. That will be correct. Okay, what else can we do? What is the connection between angular velocity and torque? Maybe you can remember some formula from our lectures. Some formula that connects angular velocity and torque. Cannot remember. Okay, it will be law of rotational motion. Law of rotational motion around the fixed axis I z derivative and is equal to mz. Okay, and what about this value? What is this and how can we find this value?
dv/dt angular acceleration. So
Yes, this angular acceleration, of course. And
yes.
what about this value?
Moment of inertia, am I wrong?
Yes, this is moment of inertia.
Inertia.
Yeah, moment of inertia. And it will be related to the axis of the cylinder. And in this case, how to find this moment of inertia? I think we have some ready formula, some ready to use formula to find this moment of inertia.
1 divided 2 multiplicate m r square. It's general formula.
1 divided by 2
By 2.
mr squared. Yes.
Mhm.
So
General.
Iz
Mhm.
is equal to mr to the power of 2 divided by
By
2.
2.
Yes. Yes, this will be moment of inertia of this cylinder. Okay, and this means that we can rewrite this equation. We can rewrite this equation and try to find angular velocity. Try to find angular velocity from here. Okay, and what else can we do with this equation, and how to get angular velocity from this?
So inertia multiplicate angular acceleration. It must be equal Fr. So x minus kmg r. So yes, both of sides is equal. So after that, minus 2 kg divided by r. Am I right? Yes, it must be.
Okay, that this derivative will be equal to minus
Yeah, minus
2
2 kg
kg
divided
divided by r.
r. Mhm.
Okay, and how to find omega from here?
Mm. outside omega. So integrate it, both
Uh,
sides.
Yes, but before integration, we should separate variables.
Yeah,
And,
dt.
so how can we do this in this case?
dt can go to right side.
Yes, yes. To separate variables, we should multiple left and right sides of the equation by dt. And we will get d omega is equal to minus 2 kg divided by r dt and dt. And now when variables are separated, we can integrate. So it will be like this. But now it is necessary to set integral limits. How can we do this?
It must be start from 0 always till t0, or let me check the question.
Yes, t will be from 0. And what about omega?
Upper. Also 0. It must be start from 0.
Start from 0. But according to the condition, we have this.
We have this, so yeah, it must be start from them.
It will be omega 0 because
Yeah.
this is initial angular
Yeah, yeah.
velocity.
Yeah. It's yeah, all right. Omega 0.
And what about upper limits?
Omega 0 plus omega t, or something like that. Omega 0 plus something must be.
It will be just omega.
Just
Just,
omega.
just omega. But we don't know. Will it be plus or minus or something else? It will be some omega. And here will be some moment time t. Okay, and now after integrating, we will get omega minus omega 0 and minus 2 kg t divided by r and omega, it will be omega is equal to omega 0 minus 2 kg
T divided by r.
divided by r. So as can we see, linear velocity increases with time, but angular velocity decreases.
This time.
Okay, maybe you have some questions about this.
So far, so good for me.
Okay, and I'll clean some unnecessary things from the screen. So what do we need? We need moment of inertia. We need velocity and angular velocity. And we need angular velocity. and we need angular velocity. Yes, and what else can we do? What else can we do? Because it is necessary to find the time period when a cylinder moves with slipping.
No sleeping. You're okay. Sleeping, rolling. So velocity must be equal omega r. Yeah, angular.
Yes,
Mhm.
yes, yes, this is correct. This is correct. This is condition of no sleeping.
Mhm.
Why? Because if we just write this cylinder, uh, let's imagine that there is no linear velocity. It is just rotation, just rotational motion. So these points of cylinder will move with such velocities. If we have angular velocity directed like this, so we will have this situation, and this velocity will be some omega zero, and what will be the value of this velocity omega zero? Well, not omega, v zero.
Wait, V0. V0. Oh, 0? Oh,
Um, no, it will not be zero
so
because
minus kgt
mm,
if it is constant. So I don't know, but we know V value on and omega value. Also, we know R.
so it will be omega r.
Yes. Mhm.
It will be omega r. And now let's add some motion from left to the right. Let's add some motion from left to the right with velocity v. With velocity v. And if we have also some motion from left to the right, what will be the velocity of slipping? It will be v minus v0. It will be v minus v0. This velocity of slipping motion. Velocity of slipping motion. And of course, when sleeping stops, this velocity becomes equal to zero. Becomes equal to zero at a moment in time when sleeping stops. It
Yeah.
will become equal to zero. And from here and here we have that v will be equal omega r. This is a
Yeah.
condition. This is a condition of stop of sleeping.
Yeah. Mhm.
And after substitution this and this, we will get k g
T.
t is equal to open bracket open bracket close bracket r. And from this equation, we can find period of time. It will be kgt is equal to omega 0 r minus 2 kgt minus 2 kgt. And time of sleep in motion will be omega 0 r divided by 3 kg. 3 kg. Okay, this is a time period when the cylinder moves with sleeping. Do you have any questions?
No, I understood. So far, so good for me.
Okay. And what about the other students? Okay. This is a time of sleep in motion. Okay, and the next part of this exercise is to find the work of force of friction that acts on the cylinder.
Sliding, yeah. Sliding.
Work of force of friction. How to define this work?
Well, is it not the same? Let's take KGT. We found already.
kgt is velocity.
Yeah.
But we need to find work.
Work. Multiplicate with meter. F multiplicate X, it must be equal work.
I don't understand.
Let me think. Uh,
Maybe you can write this.
so yeah, you're right. I forget always. Okay, so work, uh, F multiplicate X, X is meter or relation.
Yeah, you mean F multiplied by path length.
Yeah, path length. Yeah.
But
Yes.
it is difficult to find this path length because we have complicated motion. It
So
is
this is one choice. Second choice, we can use energy rules, kinetic energy. I mean,
work energy theorem.
yeah,
Okay,
maybe. I am not sure.
okay, we can use work energy theorem. Work energy theorem, and this will be better way.
Mhm.
This will be better way to use work energy theorem. According to this work, according to this, change in mechanical energy will be final kinetic and potential energy minus initial kinetic and potential energy one, and this is equal to work. this is equal to work. A is the first letter of Deutsch word arbeiten.
Arbeiten.
Arbeiten, it means work in German. So because of this, we use letter A. Okay, and this kinetic and potential energy. Finding potential energy will be simpler. What can you say about this, about potential energy?
Potential energy. In this question, it must be 0 because it's on the floor.
Yes, we can choose 0 because height of cylinder doesn't change, doesn't change, and we also don't have any deformable bodies like springs or something else. So we can put P1 is equal to P2 is equal to 0. Okay, and what about kinetic energy? For example, initial kinetic energy, K1.
K1 first time. Yeah, so
First value.
yeah. You are asking general formula, 1 divided by 2 mv square. And let me think in this question. Initial mechanical energy. 1 divided 2 multiplied inertia omega square.
Yes, it will be 1 divided by 2. It will be IZ.
IZ.
Omega 0.
Omega
Initial angular velocity divided by 2. Divided by 2. And we don't have in initial case, we don't have motion from left to the right.
Yes.
We don't have linear velocity. And in the final position, situation will be more complicated. What will be in this case?
Final. Okay. At the final, we have also rolling and sliding velocity. Oh, no, 0. Yeah. Yeah, it's a good question.
It will be both.
Well,
It will be rotational motion and the motion linear from left to the right.
Yes.
So it will be some combination of two motions.
Yeah. Okay. Also same first formula and normal kinetic formula, 1 divided by 2 mv square.
Yes, it will be EZ omega to the power of 2, but without index 0, plus m v to the power of 2 divided by 2.
Yes.
Okay, we have a formula for energies, so we can use them. We can use them to find work of force of friction. And this work will cause a heating of a cylinder and the surface. And so let's use this energies. It will be minus our formulas above. First of all, it is necessary to write m k to the power of 2, g to the power of 2, t to the power of 2, and divided by 2, plus iz divided by 2. Here it is necessary not to confuse different algebraic transformations, because it is very easy to make a mistake here. Yes, and now first term will be the same. First term will be the same, and instead of moment of inertia, we will use this mr to the power of 2 divided by 2. It will be mr to the power of 2 divided by 4, and here open brackets, and use formula for angular velocity. Formula for angular velocity. And minus omega 0 to the power of 2. Okay, let's try to open inner brackets to simplify this relation. So this will still be the same, and inside brackets we will have omega 0 to the power of 2 minus 4 omega 0 k kgt divided by r. And plus 4 k to the power of 2 g to the power of 2 t to the power of 2, and divided by r to the power of 2 and minus omega 0 to the power of 2. Okay, and let's do further simplifying. Open brackets again. Open external brackets, and let's subtract omega 0 to the power of 2 from omega 0 to the power of 2. It will be 0. And we will get m k to the power of 2 g to the power of 2 t to the power of 2. Yes, and r to the power of 2 is gone, and minus omega 0 r kgt. And it will be 3m k to the power of 2 g to the power of 2 t to the power of 2, and minus omega 0 r kgt. And now it is necessary to use this. So we'll have it is equal to 3m k to the power of 2 g to the power of 2 divided by 2, and inside brackets we will have this value of time. This value of time to the power of 2 minus omega 0 r k g multiplied by, again, let's open brackets again. We will have m omega 0 to the power of 2 r to the power of 2 divided by 6 minus the same minus similar term, but with 3 in denominator, and it will be just minus this. It is a work of force of friction. What looks surprisingly that it doesn't depend on coefficient of friction. It doesn't depend on coefficient of friction. Okay, what questions do you have?
Give me a second.
Okay. Okay, so I think that will be enough for today. If someone wants, it is possible to make homework. It's possible to make homework.
Finish off this.
Number 13.
13. 1, 10, 13. Okay. Is this final energy? Am I right? Total final energy.
It is a final value of work of force of friction.
Well, yeah, force of friction. Yeah.
Yes.
Yes. Okay. Okay, I understood.
Okay, maybe some another question.
So far, so good for me.
Okay, okay. So if it is so, thank you for your attention,
Thank you.
and I hope to meet you next week.
See you, teacher. Have a nice day. Have a nice week.
Yes, have a
Goodbye.
nice day.